This lesson is use Cramer's rule to compute the solution. Here I have two equations with two variables. So 5, 7, 2, 4 will be the matrix A. 3, 1 will be the matrix B. Okay, so A is these coefficients. B is the last part, 3, 1. We need three determinants. The first determinant is the matrix A. So using the determinant from the previous lessons, A times D, which is here, minus B times C, which is here. Simplify gives me 20 minus 14, which is 6. The next determinant is changing the first column. So instead of writing 5, 2 again, we will put 3, 1 in. Instead of 5, 2, we will put 3, 1. So we're just changing the first column only. After that, A times D, which is here, minus B times C, which is here. Simplify gives me 12 minus 7, which equal to 5. And the third determinant is changing the second column. The 5, 2 stay, but the second column is changed to 3, 1. As you can see, this is the first column, this is the second column. So we're changing the second column and put 3, 1 in. Using A times D, which is here, minus B times C, which is here. Simplify, that gives me 5 minus 6, which is negative 1. So here we have three determinants. The first determinant is the A. The second determinant is changing the first column. The third determinant is changing the second column. After that, we just divide. So determinant of changing the first column divided by determinant A gives me 5 over 6. Determinant of the changing second column divided by the determinant of A, which gives me negative 1 over 6. So these are the two solutions to this equations. Again, this is 2 by 2. Okay. Now, with 3 by 3, it's the same procedure. The only problem with this is that it is very lengthy, as you can see, because we have 3 columns. We have to do first determinant for just the A. We have to do the second determinant for the first column. We have to do the third determinant for the second column. And we have to do the fourth determinant for the third column. Again, because this is a 3 by 3, we need the first determinant for A. We need the second determinant for the first column. We need the third determinant for the second column. And then we need the fourth determinant for the third column. And as you can see, this is very lengthy. So here is our problem. I have 1, 1. There's nothing here, so 0, 3. Okay, 0. Negative 3. There's nothing here, 0. So 2, which is in this row. 0, 1, negative 2, which is here. So that's my A. And this right here, 3, 0, 2 will be my B. Again, since I have 3 columns, I will need 4 determinants. The first determinant will be just the A. Okay, the first determinant will just be the A only. Okay, so right here that I have. So the first determinant will just be the A. Okay, which I wrote it right here. And then the second determinant is changing the first column, which I have here. The third determinant is changing the second column. And the last determinant is changing the third columns. As you can see, this is very lengthy. And if the matrix is a 4 by 4, 5 by 5, 6 by 6, this can be very lengthy. So we're not going to do that. We're just going to go straight to row operation, which would be the better. And sometimes it could be faster too. Okay, so row operation would be a better method. Okay, so one more time. Cramer rule for a 2 by 2 which should be very quick, okay? However, once we get to a 3 by 3, it is very lengthy. And since there are 3 columns, since there are 3 rows, 3 equations, we need 4 determinant. The first determinant is the A. The second determinant is the first column. The third determinant will be the second column. And the fourth determinant will be the third columns. Okay, the third column. And that takes very long time to do. Okay, so 3 by 3, 4 by 4, 5 by 5, 6 by 6, and so on, using Cramer's rule is very lengthy. So the best way is use row operation, which would be a better method and sometimes faster. So I'm just going to give you the answer. The first answer will be 1/4, 11/4, and then 3/8. And let's see if row operation will give us the same solution. So here is the row operation. Again, all I did was just copy the problem again. So here is our matrix. So this part right here is this part, 302, which is in the back. So let's do the row operations. So we need a -3 to become a 0. Okay, so in this situation, we can swap, so it makes it easy. So we're just swapping row 2 and row 3. Now be very careful here. We are not looking for the determinant, so therefore we don't need that extra negative. Okay, we are looking for the solution, so do not put the negative in. Okay, like I did here, I did not put a negative here, I did not put a negative here, I did not put a negative here, because we are looking for the solutions. We only put in the negative if I am looking for the determinant. So be very, very careful. Again, yes, I am switching the rows, okay? And based on the rule, you got to put the negative in. However, that is only for determinant, okay? Since I am looking for the solutions, I don't need to put that extra negative in, all right? Now, the reason why I'm switching row 2 and 3, as you can see, there's a 1 right here, so I don't have to worry about this number right here. Since there's something right here already, I don't have to worry about it, okay? And plus, I want this to be a 0, so I don't have to worry about that as well too. So that is the reason why I'm switching 2 and 3, so that I can get a 0 here, and whatever this is, I don't have to worry about it, okay? Next, I need this -3 to be a 0, so just do the opposite, which is +3. So 3 times 1 is 3, subtract -3 gives me this 0, okay? Next, 3 times 1 gives me 3, 3 plus 0 gives me this 3. 3 times 0 is 0, 0 plus 2 is this 2. 3 times 3 is 9, 9 plus 0 is this 9, okay? Next, I want this 3 to be 0, so I brought it down here, okay? So opposite of -3, +3 will be -3. So -3 times this 1 gives -3, -3 plus 3 gives me this 0. -3 times -2 gives me -6, -6 plus 2 gives me this 8. -3 times 2 gives me -6, plus 9 gives me this 3, all right? Next, we want this 8 to be a 1, okay? So this 8 right here to be a 1. So multiply the reciprocal to the whole row 3. So 8 times 1/8 gives me this 1. 1/8 times 3 is this 3/8, okay? Next, we need this right here to be a 0. And since this is a 0 already, we don't have to worry about it anymore. So we just need to worry about this one. So we need this to be -2. So we need this to be a 0, which I have here. Since this is -2, we'll do +2 to row 3 and then add to row 2. So row 3 and then add to row 2. So 2 times 1 will gives me +2. Subtract -2 gives me this 0. 2 times 3/8, which I have right here in fractions. So 2 times 3/8, which right here gives me 6/8, plus this 2 right here, plus this 2, so right here, and then do your fractions, and it will come out to be 11/4. So I put 11/4 here. Next, I need this right here to be a 0, okay? I need this to be a 0, this right here to be a 0, so opposite should be -1. So row 2 and then add row 1. So -1 times 1 will be -1. -1 plus 1 gives me this 0. -1 times 0 is 0. 0 plus 0 is this 0. Next, -1 times 11/4 will give me this -11/4 plus 3, which I have here, and do your fractions, and that comes out to be 1/4. So 1/4 will be here. And as you can see, this and this are 0, this and this are 0, then we are completely done. Make sure the diagonals are all 1s. This right here, all this right here should be 0. This should be 1. This should be 0. And the last column will be your solutions. One more time. When you get 0 here, here, then you are done. All the diagonals right here, the diagonal should be a 1, 0, 0, 0. Then when you're done, so the last column will be the solutions. Okay, so one more time. Once you get to this, then you are done. Change the original matrix into this form, then you are completely done. No more solving. The last column will be the solution, which is 1/4, 11/4, and 3/8. And as you can see, row operations also give you the same example, the same solutions when I use Cramer's rule, okay? So 1/4, 11/4, and 3/8. One more time. Row operations give you the same solutions, okay? Same solutions as Cramer's rule, okay? As Cramer's rule. However, Cramer's rule is too lengthy. It takes too long, as you can see. If this was a 4x4, 5x5, this is very lengthy. Row operations would be a better way to do it, and sometime much faster.